So this is a question that brings together kinetics and stoichiometry. It's actually really simple. There's like not much math involved. You just have to know where to start. And so, well, this is the reaction we're given. And the first thing we're asked to compare is how the rate of O2 consumption is related to the rate of NH3 consumption. Now, since the rate of this reaction has to be uniform in terms of like both of these, it's not that we can like decide, oh, for the next 10 seconds we're going to only use oxygen, and then the next 10 seconds after that we'll only use ammonia. No, they have to be taken together, and they have to be taken up in the same stoichiometry, always 5 oxygens for every 4 NH3s. And so that can tell us really that when you're going to have a ratio of the consumption of O2 is compared to ammonia is going to be 5:4, or in other words, that's a way of saying that the rate of O2 consumption is going to be 1.25 times faster than the rate of consumption of NH3. Now, for our next question, asks us to relate how water is produced compared to the consumption of NH3. And so, again, for every, I'll write this in this bluish purple color, for every 4 moles of NH3 that are taken up, 6 moles of water are produced. So water here on the right, NH3, which to say that for every single mole, let's divide both these numbers by 4, so we get 1. 6 over 4, that's 1.5. For every mole of NH3 that's produced, we have 1.5 moles of water. Pardon me. For every mole of NH3 that's taken up, we have 1.5 moles of water produced, which is to say the rate is 1.5 times faster of water production than